Okay, today we're going to be doing lesson 2.8, multiplying fractions. We're going to start this lesson with a video.
In this lesson, you will learn how to multiply proper fractions using rectangular models. You already know that a proper fraction is a fraction with a numerator that is smaller than the denominator. Proper fractions always have a value that is less than 1. For example, I can split this whole rectangle into thirds. Then, I can shade 2 of the thirds. This makes the fraction 2 thirds, which is a proper fraction. If I had the fraction 4 thirds, this would not be a proper fraction because the numerator is bigger than the denominator. This 4 thirds can be converted into 1 and 1/3. This is a mixed number because it has a whole number part as well as a fractional part. You also know about common denominators. Common denominators just means that denominators in 2 or more fractions are the same. In this picture we have 2 thirds, and in this picture 1/2. The common denominator for these two fractions is 6. Once we have fractions that have common denominators, they can be compared, added, and subtracted. When we multiply and divide, we do not need common denominators. I'm going to explain why common denominators are not needed when multiplying fractions by showing you what happens when we overlay models of proper fractions. Let's return to the 2 thirds and 1/2. We can change the colors to distinguish between these two fractions. In addition, I will leave the 2 thirds split vertically, and the 1/2 we will change to split it horizontally. This will allow us to overlay one fraction on the other. Notice when the 2 thirds is overlaid by the 1/2, the original 2 thirds is split into 2 pieces. This leaves us with 2/6 shaded by both fractions. Using the basic multiplication of fractions process, where we do 2 thirds times 1/2 by first multiplying the numerators, 2 times 1 is 2, and 3 times 2 is 6, we get the same answer of 2/6. This can then be simplified to 1/3. What's interesting about this process is that if you remember, when we found the least common denominator for 2 thirds and 1/2, we got 6ths. Notice that the common denominator of 6 was created when we overlaid the two models. It was also created when we multiplied numerator times numerator and denominator times denominator. The 6th was created through the multiplication process. This is why you do not need to find common denominators before you begin multiplying. Let's see how this same process works in another problem. 1/4 times 3/5. Here we have the 2 wholes, and we are creating our fractions. The one on the left is divided into fourths, and the one on the right is divided into fifths. We can then shade the appropriate parts. Finally, we can overlay the one fraction on the other. Notice that when we do this, it divides the original whole into 20 pieces. Then, out of those 20 pieces, 3 of the 20 are shaded by both fractions. This answer of 3/20 matches the process of numerator times numerator and denominator times denominator. In this example, we do not need to simplify because 3/20 is already in its simplest form. You have just learned to multiply proper fractions using rectangular models.
Okay, so let's give this a try. In the first example, part A, we're going to take a -2 times a -1/3. Now, recall, all whole numbers can be written as fractions, and you will want to do this. All fractions over 1, they are improper. So we do not need to get a common denominator, as we did in adding or subtracting, but we will multiply the numerators and then multiply the denominators. Remember that with the integers, the negative fractions, let's keep the numerators negative. So using the rule, we would have negative 2 times negative 1, and divide that finally by, or write that over, 1 times 3. If you multiply, you will get 2/3. Remember, it's positive because the rule for multiplying integers, if they are like signs, the answer will always be positive. Let's try another. In negative 3/10 times 5/6, you could still write the product of the numerators over the product of the denominators. And you can see that there are some common factors in the numerator and in the denominator, and so you may have in the past cross-canceled or canceled out the common factors. So between the 3 and the 6, I can divide out a factor of 3, and between the 5 and the 10, I can divide out a factor of 5. This will make the multiplication process easier because I'll be working with smaller factors. So if I cancel first, I would get negative 1 times 1 in the numerator and 2 times 2 in the denominator. So a negative 1/4 is my answer. Again, go back to the original problem. You have a negative fraction times a positive fraction, so that makes sense that my product or my answer would be negative. How about you try this one? Negative 5/12 times 9/10. Remember to write your numerators over your denominators, so we will multiply the numerators together, negative 5 times 9 over 12 times 10. You could cross-cancel any common factors. We can cancel a factor of 5, and we can cancel a factor of 3. So 5 divided by 5, or negative 5 divided by 5 is negative 1. 10 divided by 5 is 2. 9 divided by 3 is 3, and 12 divided by 3 is 4. And simply multiply negative 1 times 3 and 4 times 2 to get a negative 3/8. All right, let's look at this problem. A postcard is 5.5 inches long and 3 3/4 inches wide. Find the area of the postcard. Remember that in our area, to find area, we'll take the length times the width. So we'll have two mixed numbers, and we'll multiply those together. So you can write the formula, length times width, substitute in the values, 5.5 times 3 3/4. Now, in order to multiply these two mixed numbers, it is necessary that we first put them into improper fractions. Remember that by doing that, we will take 2 times 5 for 10 plus 1 to get 11 over 2. For the second one, 4 times 3 is 12 plus 3 to get 15 over 4. So once you get those into their improper fractions, you could continue with the multiplication algorithm, multiply 11 times 15, and put that over the product of 2 times 4. Look for anything to cross-cancel. I don't see anything, so we might have a very large numerator. 165 over 8. Now when you have an improper fraction, remember to simplify that. We're taking 165, dividing by 8, and then writing the remainder as a fraction over the denominator of 8. And in this case, we want to make sure to include the units. So our final solution here for the area of this postcard would be 20 5/8 feet. Well, darn. Thank goodness for erasers. That would be an awfully large postcard. Let's try inches squared. So remember at the very last step to always go back and check your work. Okay, how about you try? You have 5.5 times a negative 1 5/6. Remember, we talked about the fact that if you're changing a negative mixed number into an improper, cover up the negative sign first. Change the mixed number to improper and then bring back the negative sign in the numerator. So we have 11 over 2 times a negative 11 over 6. Multiply your numerators, and then multiply your denominators, and then change it back to a mixed number. Your final answer would be negative 10 and 1/12. The last example for today, let's find the area of this rectangle. First thing we're going to do is change the mixed number to an improper fraction. So 3 times 1 plus 2 is 5/3. We're going to multiply that by 5/6 because it's length times width. There is nothing to cross-cancel between the numerators and the denominators, so I'm going to simply multiply 5 times 5 and put that over 3 times 6. So 25 over 18. Through division, I can divide and get a mixed number of 1 with the remainder of 7 over 18, and this unit will definitely be feet squared. That concludes our notes for today.